Hey guys, I know that this is not ideal and I'm going to get better at this, but for right now, I have a laptop looking at the board and I'm going to teach from the board. So let's get started. I'm going to go ahead and introduce the next unit on electron configuration. That's going to be Unit 3. As you probably saw in Canvas, we are not going to do a test on Unit 2. We can talk about that whenever y'all are at school, Wednesday or Thursday, but for today, we're just going to go ahead and start the next unit. This one is actually a pretty short unit. It's pretty easy to pick up on, and this will carry you through pretty much the other units on how chemicals behave. So, Unit 3, Electron Configuration. So first of all, I have to tell you about how electrons behave. Electrons behave as waves. Now, it's a particle because it's a part of the atom, but the electrons are going to travel in like with wave properties. They're moving around the nucleus. Remember, the electrons are negatively charged particles, and they are attracted to that nucleus because the nucleus is a positive charge thanks to the protons. Okay? So, what keeps the electrons from actually coming in and bombarding the nucleus and causing something else to happen is that electrons are moving super fast. Okay, they're really light and they're constantly moving, and that momentum that has built up is causing them to not have any kind of reaction. Okay, well, because we're going to talk about waves, let me just remind y'all that there's something called electromagnetic radiation. And again, we are not going to have to do a lot of notes on vocabulary and stuff, but I just want to make sure that when I talk about properties of waves that you guys are familiar with what those terms mean. Okay? So electromagnetic radiation, that's just going to be all energy in the form of waves. So you learned about this in probably middle school. Different types of waves. There's the visible light waves that we can see. There's microwaves, radio waves. There's even infrared, ultraviolet, all those things. Okay? Waves look like this. They have different parts. So from crest to crest, you have a wavelength. The top to the bottom, the origin to the bottom or the origin to the top is your amplitude of your wave, and from the bottom to the bottom, that's also a wavelength, and the bottom of the wave is the trowel, the top of a wave is the crest. Okay, so different components of a wave, these are kind of important for you guys to keep in mind, so you might want to write this down. And I could have sworn that I have a pen feature turned on, but maybe I didn't. Who knows? So with different components of a wave, you have the wavelength. And the wavelength is going to be the distance from the trowel to trowel or the crest to crest. Then you have the amplitude and the frequency. What you guys need to keep in mind is that your wavelength is in terms of meters, nanometers, and centimeters. Honestly, we're not really going to have to do any kind of calculations on these. The kids do in physical science. I used to have to teach this, but it's not in our standards anymore. But I just want to make you aware that there is some math that goes along with this. In the electromagnetic spectrum, there's only a really small part that we can see, and that's going to be the visible light waves. So visible light waves, the red side is going to be the slower waves. They're the longer wavelengths, and they travel a lot more slowly. They have less energy. You have on the purple side that's getting closer to the gamma waves, those are the shorter waves, a lot more higher frequency, so they're hitting whatever surface a lot faster, and they have a lot higher energy. So it's kind of like if you were going to shoot a laser. You don't want to shoot this really long beam. You want to shoot a lot of short beams, and that gets the energy to the substance. So radio waves, we listen to the radio all the time, right? Well, radio waves are really low energy. On the other end are gamma waves. Those are right beside X-rays. You know that you can't be exposed to X-rays all the time because they can be harmful, and those are the higher energy waves. Well, If we were doing calculations, which we're not, we would have to convert the wavelength, or find the wavelength if we knew the frequency of a wave, and that's really fun. It's really not that bad to do the math, but we're just going to skip this, okay? So then I also want to make you familiar with another term. It's called a quantum. So please write this down. A quantum is just the increment of energy that atoms possess. So they can gain or lose energy in these little specific amounts. Okay, so this is what a quantum is. Quantum is singular, quanta is plural. So copy that down for me. Just to give you a little background, there's this scientist, his name is Max Planck, and he introduced this concept, and he was able to find through a lab that we're going to be doing that light can travel in specific amounts, and you're going to get specific colors of lights that represent that amount. So that's kind of cool, because whenever we do this lab, we're not only going to be playing with some fire. Yes, I said we're playing with fire, but in a really safe way. So we're not really playing and exploring with fire, we're just going to do something with fire. And we're going to see different colors. Those colors are specific to the energy of the wave. Well, I told you about energy, but we've only seen wavelength and frequency. Well, guess what? There is another formula, which we're not going to have to do any math with, but it says energy equals this constant called Planck's constant times the frequency. So we have energy equals some constant times frequency, and in this previous slide we see that the speed of light is equal to the wavelength times the frequency. These are little Greek letters. So anyway, I just wanted you to see that they are definitely related, and we're going to be doing something called, see if I took a picture of it, called an atomic emission spectrum. Okay? So, I would love for you guys to copy this slide also. It just says that an atomic emission spectrum, AES, is when you get discrete or separate bands of light that the electrons release. We'll talk about this when we do our lab. So, every element is going to have its own unique spectrum. It's like a fingerprint. And how they give off light? Well, we're going to go into this into more detail, but if you want to copy this, go ahead, okay? And I'll give you a few minutes. And so basically, when you come to class tomorrow, we're going to talk about the possibility of just going ahead and taking a test, because you may or may not feel ready with the structure of an atom. Or plan B will be to go ahead and start a lab. Now, if we do the test tomorrow or Thursday, then what we'll do is when you guys come to school on Monday and Tuesday, we'll do the lab then, okay? So, I want you guys to let me know what your preference is, and I also need you to copy this down. Okay? So you can pause that video if you want, and you can copy it down. I'm going to go ahead and close out this particular video, and that's it for today. Thank you.